Astronomers detected mysterious radio signals from Comet 12P/Pons-Brooks. The cosmos never stops surprising us. Just when scientists thought they had seen everything, a strange and completely unexpected discovery changed that belief once again. Astronomers around the world have now detected radio signals coming from Comet 12P/Pons-Brooks, and what they're hearing is unlike anything we've ever recorded before. Comet 12P, often nicknamed the Devil Comet because of its two bright horns during outbursts, has already fascinated scientists for months. But this new signal takes things to an entirely different level. At first, observatories monitoring the comet picked up what seemed like random noise. But after deeper analysis, that noise revealed a structured pattern, a repeating pulse at a very precise interval. Something in the coma of the comet was producing rhythmic radio waves. Naturally, the world of astronomy erupted with questions. What could generate such a precise and periodic radio emission? Was it the comet's magnetic field interacting with solar wind? Could it be plasma oscillations inside the comet's tail? Or something far more mysterious? Teams from NASA, the European Space Agency, and multiple university observatories began cross-checking the data. The signals were confirmed. They weren't instrument errors. They were real. The radio bursts came directly from Comet 12P/Pons-Brooks, traveling millions of kilometers through space before reaching Earth. What made this so strange is that comets aren't typically known to emit radio frequencies in regular patterns. They can produce electromagnetic noise due to ionized gases, sure, but not like this, not this organized, not this consistent. The pulses had intervals measured down to fractions of a second, stable across multiple observations. One theory suggests that as the comet approaches the sun, volatile materials like carbon monoxide and water ice vaporize rapidly, creating intense jets of plasma. When these jets interact with the solar magnetic field, they could behave like a natural radio transmitter, generating oscillations that are detectable across vast distances. If that's true, this could give scientists new tools to understand how plasma behaves in small celestial bodies, almost like a window into the birth of space weather itself. But not everyone is convinced that the explanation is purely physical. Some scientists have quietly admitted that the regularity of the signal resembles artificial transmission patterns, similar to what we've seen in pulsar studies or even in early SETI detections. That doesn't mean it's alien communication, of course, but it does show that nature can sometimes mimic technology in ways we never expected. As the data poured in, radio telescopes in Chile, Japan, and California coordinated a 24-hour observation of the comet. During one of these sessions, the comet suddenly released an outburst, a massive explosion of gas and dust, and the radio pulses changed frequency almost instantly. It was as if the comet was responding to its own eruption. The rhythm slowed down, then sped up again, and then stabilized. It wasn't random. It followed a mathematical curve. That discovery set off a wave of excitement online. Astronomy forums and science Twitter were flooded with discussions. Is this proof that comets can act like natural radio beacons? Could they have been sending these signals for centuries, unnoticed by human technology until now? To understand how extraordinary this is, remember that 12P/Pons-Brooks is not an ordinary comet. It follows a 71-year orbit and is expected to make its next close approach to the Sun in 2024. It's already visible to telescopes as it brightens in the night sky, releasing enormous clouds of glowing gas shaped like devil horns, an optical effect caused by uneven jets from its surface. And now, as it nears the inner solar system, its magnetic and electrical interactions are intensifying. That's likely what's giving rise to the strange radio patterns we're now hearing. In one striking moment during analysis, astronomers compared the comet's emissions to signals from Jupiter's auroras and found similarities. It turns out, when charged particles from the solar wind hit Jupiter's magnetosphere, they produce radio emissions almost identical in frequency to what we're seeing from the comet. Could comets, in their own small way, be miniature versions of planetary magnetic systems? If that's true, this could revolutionize our understanding of cosmic magnetism. Comets could serve as natural laboratories for studying plasma dynamics, electromagnetic waves, and even the origins of space radio bursts that we've been detecting for decades. But then came another twist. When scientists compared the signal with archived data from the Rosetta mission, the spacecraft that orbited Comet 67P, Churyumov-Sagaris-Menko, they found weak traces of similar oscillations back in 2015. That suggests that this phenomenon might not be unique to 12P/Pons-Brooks. It could be a universal property of comets themselves, one that's simply been hidden from us until our instruments became sensitive enough. In a broader sense, this discovery connects to the mystery of fast radio bursts, FRBs, those sudden, millisecond-long explosions of radio energy that have puzzled astronomers for years. Could some of those signals actually come from comets during moments of extreme outburst? It sounds far-fetched, but several researchers are beginning to explore the idea seriously. Meanwhile, space agencies are already planning new missions. If a future probe could carry a dedicated radio spectrometer to a comet, we could finally measure these signals up close and identify their exact source. That could open an entirely new chapter in the study of how electromagnetic fields evolve in small bodies, and maybe even uncover processes that were present during the early formation of our solar system. But there's also a poetic side to this discovery. For the first time, we're not just seeing a comet, we're hearing it. The sound of a cosmic wanderer traveling for millions of years through the void, now whispering its electromagnetic song to the tiny blue planet it passes by. It's a humbling reminder that the universe is alive in ways we barely understand. Whether these signals turn out to be natural plasma emissions or the byproduct of something more complex, one thing is clear. Every discovery like this brings us closer to understanding the deep, mysterious harmony of space. The cosmos isn't silent, it's singing. And Comet 12P/Pons-Brooks just joined the choir.